On many of the channels I follow, one topic that arises frequently is simulation theory. I don't take this topic too seriously, nor discussions about it, as they're usually tainted with science fiction themes, and often not very well grounded. There is something to the idea, though. I think if we're careful, we can derive some interesting insights from exploring it. But first things first, what do we even mean by simulation? As opposed to what? Reality? Well, what do we mean by reality? This is why I usually chuckle when I hear engineers and scientists talk about this topic. It's well below the rigor of mathematics or physics. Let's give it a shot. What we'll find, I believe, to be valuable philosophy, and yes, that is where I believe this topic fits best. Is there a common denominator to what we mean by simulation and reality? Yeah, there kind of is. Computation of some kind. Could we say that the common denominator of what we mean by simulation and reality is a computational substrate? This really isn't too much of a stretch. Both classical and quantum computation models are derived from natural effects. Nature obviously computes. It is a computational substrate. We exist within a computational substrate of some kind. In this brief conversation, we'll ignore the topic of the genesis of computational substrates to avoid infinite recursion. But if we accept this common denominator, we can now relate the two. Reality is the perfect simulation. Or perhaps better said, reality is a simulation that optimally utilizes the computational substrate. The problem with definitions sometimes is they take away the magic or fantasy out of our sails. We are now no longer talking about alien computers, but rather the efficiency of abstractions. A necessary change of pace, in my opinion, to get to the bottom of this subject. Before that, let's start with our own computers. As our ability to build more powerful computers progressed, an interesting software phenomena arose: virtualization. We began to write software that pretended to be a computer. Virtualization brings with it numerous advantages. Initially, these advantages were not sufficient to actually replace physical servers. As virtualization technology matured, this changed. Jump forward to today, and when we say server, we almost always mean a virtual server running on a virtualized hardware. There is a fundamental change that occurred to the way we implemented virtualization that allowed this to happen. In order for virtualization to be fast enough to replace a real server, it had to become something different. No longer a simulation of a computer, it became a filter on top of the physical hardware, a pass-through with certain constraints, a sandbox, a partition, a time and resource slice, borders and boundaries right on top of the actual computer. A constrained region with rules and conditions that are tuned and controlled separately from other regions. Wait, could we come up with a better way to describe the relationship that a simulation has with its superset reality? A constrained region with rules and conditions that are tuned and controlled separately from other regions? If this is what a simulation really is, then we're not just living in a simulation, we are drowning in a sea of simulations. Some good, some bad. Governments, universities, companies, Fortnite, World of Warcraft, all fit into this definition. Life is the very pursuit of a better simulation, a better pass-through filter to the substrate. And the simulation that everyone's talking about, the final and ultimate abstraction that we're all stuck inside of, that actually isn't a simulation at all. That is reality, and everyone has it backwards.